Now, let's talk a little bit about complex meshes, level of detail, and physics. If we have something as complex as this, as you can see, lots of tiny details, lots of very, very tiny details in here, for example, then what you end up with if you were to upload this and select this as your physics model is you would have all these tiny parts would have their own little collision, and that adds a lot of resources. That adds a lot of overhead to a simulator. It needs to calculate all these tiny collisions, all this small stuff, and you don't want that. So ideally what you do is, because the basic outline of this is a box, you would create a secondary mesh, this one, which is just a basic box. And we're going to use this to collision for this highly detailed mesh. So instead of colliding with all this small stuff, you're just colliding with this box. All that exported, what we end up with in our upload dialog, if we go in and upload the two things, so you start with your normal mesh, the visual one, and you end up with this. All these details in there. Now, you have these three additional settings here for level of detail. Now, what level of detail is depending on the distance that you're looking at an object, there's different levels of the amount of detail that is shown. The reason this is done is because the further away you look, the more stuff is on screen. If you have one of these boxes that you're just looking at, then it's fine. You can see all the details, you can have all these tiny little stuff that you put in there. That's perfectly fine, because there's nothing else on the screen. But let's say you have 1,000 of these boxes, and you're looking at all of them at the same time, and they're all as detailed as that. Well, every tiny detail has to be rendered, every tiny detail has to be shown. And even though most of these boxes at the distance are no more than a handful of pixels, your graphics card still has to calculate. So it still has to go in and approximate how the box will look from that distance. Now, what you do to alleviate that problem and to reduce the load on your graphics card is you select different level of detail. Now, thankfully, OpenSim and your viewer will approximate the level of detail for different distances. That's what these things are, the medium, the low, and the lowest. So if we go into our preview window here, this is the highest. This is when you're looking at it very close, just having that on the screen. But let's say you have 20 on the screen. You don't want all of that detail, no. You have this much. And that is generated by the viewer. You don't need to do anything else. Now, you can supply different level of detail if there is something specific that you want to have shown at all times. But the generation here is actually pretty good for what level of detail is about. So as you can see, we're losing some of the finer grained detail, but you can still tell that this isn't just a plain box, that there is some stuff engraved into it. Now, let's move further away. Now we have this. Well, that looks a bit weird. Maybe we can change this a little bit. Maybe we can make it a box again. Well, what you can do, using the generate system, you can change the amount of triangles that are supposed to be shown. So if we up this a little bit, eventually, yay, we have a box again. So that is then for if you have, I don't know, 500 boxes. So what if you have 1,000 boxes? What if you have the entire region filled up with it, and you're looking at the entire region? Well, you go down to the lowest level of detail, at which point, yeah, it will look a little bit janky. But what we can do at this distance, for example, we can say, use from file, aka load from file, and we can select our little physics box that we've made, the simple box, to show. Or we could say use the LOD from above, but I would highly encourage you not to do this. If you set all of these to use the one from above, aka use the highest one, what you end up with is a lot of these boxes on a region will tank your frames down to single digits, because all the details of each individual box has to be approximated, because at that distance, that box is just a handful of pixels instead of the full 1080p of your screen. And the graphics card has to work extra hard to make sure that all of the details are approximated in the handful of pixels that it actually shows. So, back to our physics. We have sort of said, okay, this is what we want the thing to look like on a different level of detail, but we don't want to use that for our collision, hell no. That would be insanely complex to compute all these different tiny things colliding with each other. No, what we do is we go to our physics tab again, and instead of choosing one of the LOD levels that we have, we say from file. What we now can do is we can click on browse, and we can actually select the box that I've shown you before, our collision box. And we select that instead. And what you can see now here, the yellow stuff, that's just that box. No collision with all these tiny parts, just the box. Just that yellow thing that gets collided with, nothing else. So we upload that. And what we end up with here is our box. And all that lovely tiny detail, as you can see. But if we go to our physics shapes, as you can see, if I zoom in here, we're not colliding with this part. We're colliding with this part up here. You know, we're colliding with what's invisible from here, this box. So we're not colliding with all these tiny details here. We're just colliding with a very basic box, just like your basic prim. That's all we're colliding with. That significantly reduces the load on the simulator. It significantly reduces the load on your viewer as well. And moreover, because we have selected proper level of detail and not just the highest one, as we zoom away, there's less and less detail shown, and our frames stay nice and smooth, even if more stuff is shown.